All right, so now that we have discussed the background voting knowledge you will need for this project, let me now just briefly talk about the code requirements themselves. What must your code do, and what must it look like? Okay, so the overview of the code is this. You're going to use simulation. As we've done plenty of times before, the example that comes to my mind is Chuck-a-Luck. Some of you did a bonus question where you investigated win probabilities in craps, but we've used this technique before. You make the code run 100,000 times or 1,000,000 times or whatever and just get sort of a hit rate for what you are interested in. You're going to do it in this project involving instant runoff voting and plurality, these two voting methods from the background knowledge document. And I should just say real quick, this kind of thing is routinely done by mathematicians and poli-sci people who have like a mathematical bent to their research. So what you're doing is similar to what like statisticians do, mathematicians do, whatever. And you now have the power to do that because you know some Python. You are essentially at like a research horizon in social choice theory because of your Python knowledge. And that's really nice. Okay, so the point of this project is that you can use the programming knowledge you have to investigate problems that can be incredibly difficult or perhaps impossible to analyze without programming. So I think I said this in a previous video, but the kind of results you're going to get here, these probabilities you're going to get, are extremely hard to calculate using a theoretical framework, okay, to calculate from first principles. So you don't have to. You guys don't have to calculate these probabilities from theory or from first principles because you have Python. Python lets you estimate things like that. And that's really nice. Okay, so here are the project instructions. You're going to use 100,000 runs to calculate the probabilities. I'll show you in a second. It's assumed that each 3-candidate election is as likely as any other. This is known as the anonymous impartial culture assumption in the literature. And as I said in the other document, an election outcome means a list of 6 percentages that add to 1. So an election outcome is a list of length 6, as discussed before. So for each run of the individual 100,000 runs you do, you start by choosing an election outcome at random. I wrote a function that does this. That's not part of what you have to do. It's on Moodle. So you need to grab that function and use it. That function returns a list of length 6, where each item in the list is a decimal representing a percentage of people who voted in that particular way. Your code needs 5 functions. Okay, so I'm not going to read this to you, but you need a function that calculates the instant runoff voter winner, the plurality winner, a function which which returns the Condorcet candidate of an election if there is one. There might not be one, right? If a Condorcet candidate does not exist, the function should return something that indicates to you that there wasn't such a candidate. A function called spoiler exists plurality. So this function, you can sort of read here how it's supposed to work, but determines whether or not a given election contains a spoiler candidate when using plurality. So recall, to be a spoiler, you can't just be a spoiler in the abstract. You have to know which voting method you're talking about. So this function will think about plurality spoilers. The next function does the same thing but with instant runoff voting. Determines whether or not a given election contains a spoiler when using instant runoff voting. This function, by the way, will look pretty similar to the plurality one. So once you've written that 4th function, this one should flow pretty easily. And your code should use these functions as functions. These functions should be their own little worlds. You got to call on them appropriately, etc. Here are the probabilities I want you to estimate. Okay, and that's what the 100,000 runs will let you do. Assuming a Condorcet candidate exists, the probability that plurality selects this candidate as the winner. 2, just change the word plurality to instant runoff voting. So then you can compare, sorry, there's a typo here. I'll fix it when I upload it to Moodle. This probability can be compared to that from 1, right? So recall one of the claims in the popular press, although they don't use this language, but one of the claims is that instant runoff voting is more likely to choose a Condorcet candidate than plurality does. And that's good, we think, because Condorcet candidates are like broadly appealing. They are consensus candidates, whatever. So these two things combined will let you investigate one of the claims from that document. And then same thing with spoilers. The probability a randomly selected election contains a spoiler under plurality and then under instant runoff voting. So again, you could compare these two things, right? Under which method is spoilers a bigger problem? Are spoilers a bigger problem for plurality or for instant runoff voting? The popular press, at least the articles I found, claims that spoilers are less of a problem for instant runoff voting. They are more of a problem for plurality. Is there any evidence to back that up according to your code? And then finally, somebody claimed from one of these articles that instant runoff voting and plurality choose the same winner a lot of the time, and the number they gave was 90% of the time. So you can investigate that. These are the 5 probabilities I want you to estimate, and this is the point of the project. And again, I just cannot emphasize this enough, how nice it is that you guys even can investigate these questions. You guys are not getting your PhDs in voting theory, right? That's just not what you're doing. You guys are in an introductory programming course. Yet, you can answer these very deep questions, actually. Or you can estimate answers, right? Get pretty good estimates of answers of these deep questions that are hard to answer without programming. But you guys can do it in like a week or so, however long it takes you to build the code. Okay, so that's all the materials for this project that I think you need. Please contact me with questions if you have them.